Welcome to Demystifying Math. In this lesson, we're going to be discussing linear and angular speed. Let's start at the very beginning. The circumference of a circle is 2 pi times the radius, or pi times the diameter. If your radius has a length of 1, then the circumference is 2 pi. This is the distance traveled around the circle, which is called a linear measurement. We could also express the distance traveled around the circle as 1 revolution, which is an angular measurement, or as 360 degrees. Since they're all representing the same movement, they're all equal. So 2 pi is the same as 360 degrees, which is the same as 1 revolution. Let's talk about radians for a minute. 1 radian is the same as 1 radius length. So what we've done is drawn a circle where the arc length from A to C is the same as the length from A to B on the segment, or the radius. How many of these radius lengths will we have to go around the circle once? Well, what we could do is figure out the circumference of the circle, and since our radius length is 5, our circumference is 2 pi times 5, or 10 pi. Then we're going to divide 10 pi by 5 to get how many radius lengths we have going around the circle. And that's simply going to give us back to 2 pi. Now, it really wouldn't matter what our radius length was. We're going to take our circumference and divide it by r, and the r's cancel out, so we're left with 2 pi. 2 pi is about 6.3 radians. So that means that we have 6.3 radius lengths of arc lengths going around the circle. So I drew that on this diagram here, and you can see that we have 6 arc lengths that are the same, and then a little bit more, which is the 0.3 radians. So what we can say is that 2 pi radians is equal to 360 degrees. So how many radians is 1 degree? Well, we're going to take 2 pi and divide it by 360 to get pi over 180 radians for 1 degree. So that gives us a conversion factor to go from radians to degrees, or degrees to radians. So what we're going to do is figure out how many radians we have if we have 30 degrees. So we're going to take 30 and multiply it by our conversion factor, and we get pi over 6. So 30 degrees is the same as pi over 6 radians. Okay, let's find an arc length. We want to find the arc length going from the positive x-axis up to the segment that's marked at the terminal side of the 30-degree angle. To get an arc length, it's really just a portion of the entire circumference. So we're going to take our circumference, which is 2 pi r, and multiply it by the angle divided by 360 to get our portion of that circumference. Then I simplified a little bit. I had 2 over 360, which I simplified to 1 over 180. And then what I did was I switched the placement of pi and theta. And I did that so you can see that we're taking the angle theta, which is in degrees, and multiplying it by pi over 180, which means that we're changing it to radians. So we can simplify our formula a little bit if our angle is in radians, because then the arc length is simply going to be theta times the radius. Now think about this. If your radius length was 1, then your arc length would simply be the measure of that central angle in radians. Okay, so for this case, we had a 30-degree angle, which a few minutes ago we converted to radians as pi over 6. So we're just going to take pi over 6 and multiply it by our arc length, which is 5. And you can tell it's 5 because it's drawn on the coordinate plane. So you have 5 pi over 6 as your arc length. Okay, so here's a question for you. Which one of these circles is moving the fastest? You're probably thinking that the outer one is moving the fastest. If you're thinking that, you're probably right, because that would be considered its linear speed. The outer circle is traveling a greater distance than the other 2 circles in the same amount of time. So it would be traveling faster. But we can think about it another way. We can think about the distance traveled as an angle over time. And now you can see that all three circles would be moving at the same rate when you talk about angle divided by time. Okay, so what we saw is that all three circles are traveling at the same angular speed, but at different linear speeds, and that the outer one is traveling the fastest as far as linear speed goes. So there's a relationship between angular speed and linear speed. Your angular speed is going to be your angle divided by time, which could be measured in anything like revolutions per minute, degrees per second, radians per hour. When we talk about linear speed, we're talking about velocity, which is distance divided by time. Since our circles are traveling in a circular motion, the distance is going to be the arc length measurement. And we found a formula for arc length a few minutes ago, which was the angle times the radius length divided by time. Now, oftentimes you see this formula for velocity as r omega, where omega is your angle divided by time. When you're talking about velocity, you're talking about feet per minute, inches per second, centimeters per hour, anything that would give you a distance divided by time. Okay, so here we have a ceiling fan, and its blades are 52 inches in length. The fan blades are rotating at 5 revolutions per second. We want to find the linear speed in feet per second of the tips of the blades. Notice that I said the tips of the blades, because what we just saw with those three circles is that at every point along those blades, you're going to have a different linear speed. So we're just going to be concerned with the very tips of the blades right now. Okay, so our first step, we're going to convert revolutions to radians to get omega. So since we know that 1 revolution is 2 pi radians, 5 revolutions is going to give us 10 pi radians. So that gives us omega, 10 pi radians per second. Next, we're going to convert the radius length from inches to feet. Then multiply omega by the radius to get the linear speed, or the velocity. So remember, velocity is r omega. So we have, in this case, 52-inch blades, which we're going to convert to feet. So we have 4 1/3 feet. And we're going to multiply that by the 10 pi radians per second that we found. So that's going to give us 43 1/3 pi feet per second. Now, notice that I left off the radians because that's really just like a count, how many radius lengths you have. So your real units of measurement are strictly going to be the feet and the seconds in the denominator. So this approximates to about 136.14 feet per second. Okay, we have a car that travels 35 miles per hour and has 24-inch wheels. How many times will the wheel turn in 1 hour? Okay, so here we have a wheel, and it's going to be traveling along this line, which you can consider a street or whatever. What I want you to notice is the distance from A to B, which we have here, and this arc length, or in other words, the distance that D has traveled around that circle, are going to be exactly the same. So no matter where we are on this circle, we've traveled that distance. So what we want to do for this particular problem is divide the circumference of the wheel or the tire up by the length that's been traveled. So our first step in finding the answer to this problem is to find the diameter of the wheel, and that's given as 24 inches or 2 feet. So we converted to feet because we had miles per hour there, so we're going to work on that. So we want to find the circumference of the tire, which is 2 pi times the diameter, pi times the diameter, which is 2 pi feet. And then what we want to do is convert from miles per hour to feet per hour, so that everything's in like units of measurement. Alright, so we know that 1 mile is 5,280 feet, so we're going to multiply by 5,280 feet per mile. So that's going to give us 184,800 feet per hour. Now to find revolutions per hour, we're going to divide feet per hour by the circumference of the tire. So you have the 184,800 feet per hour times revolution per 2 pi feet. This 1 revolution is 2 pi. And that's going to give us 29,411.83 revolutions per hour. Okay, let's look at our next problem. The tires of an automobile are 26 inches in diameter and are revolving at a rate of 480 revolutions per minute. This time we're going to start with revolutions per minute, and we want to get back to miles per hour. So the first thing that we're going to do is convert our revolutions per minute to revolutions per hour. We can do that by multiplying by 60 minutes per hour. So we get 28,800 revolutions per hour. Then we're going to find the circumference of the tire in miles. So we're going to convert. So we have 26 inches, which we can convert to feet by multiplying by 1 over 12, and then convert that to miles by doing 1 mile per 5,280 feet, which I wrote as 26 over 63,360 as an exact number, so I didn't have to estimate it at all. So the circumference is pi times the diameter. So we're going to get, in lowest terms, 13 over 31,680 pi miles. Now we're going to multiply the revolutions per hour by the circumference of the tire. So I used the 26 pi over 63360, but you could put the lowest terms in there if you want to. Then I just multiplied straight across, and I got 37.1 miles per hour. Okay, thank you for tuning in to Demystifying Math.